Hello viewers. So today we are going to see what is Minnaert Topographic Correction. Usually it occurs in mountainous region. It is actually varying terrain slope aspect cause uneven solar illumination, like sun facing slopes appear artificially bright while back slopes fall deep into deep shadows. The Minnaert topographic correction method normalizes these illumination differences by treating the surface as a non-Lambertian reflector using an empirical constant to model surface roughness. So basically it removes the surface roughness and make it topographically correct. Okay, for this we need basically three things. So first one is satellite imagery, and then the dim data of that particular study area. Obviously we need this solar metadata, which is already in our satellite imagery catalog when we download the data. So basically it's going to be a very long process actually. So we'll split this whole process into 4 steps. First we'll calculate the terrain geometry and we'll convert into radian, and then we'll calculate the illumination model, and then after that we'll calculate the Minnaert constant, which is the very important part of this process, which actually define the accuracy of the whole process. And then finally we'll apply the final Minnaert correction, and then we'll get the final output result. Okay, so let's get started with our ArcMap 10.8. so I have my dim data clipped with my AOI, and the same AOI with the same AOI I have the optical band, that is Landsat band 3. So the third data is required is the MTL file, which is this can be like when we download the data, it will look like this. And then when we open this, you can visualize this data as text document, and you will click this, then you will get this file, and you will get the solar data here, sun azimuth and sun elevation. Okay, so only these two values are required for our calculation. So we'll start with our calculation. So I am using my data, and I have already opened this in text notebook. Okay, so for this calculation, this is actually in degrees, and we have to convert it into radian for the calculation. So we'll simply copy these values in Excel file. So we'll create our own and copy these values. Okay, so we'll copy these values, Control C, and then paste it here simply. So this is actually, we have the two values, so we'll cut this and paste it in another column. Okay, I'll do the same for this. Okay, now we have the sun azimuth and sun elevation, but what we require is the sun elevation, sun azimuth, and solar zenith angle. So what is the solar zenith angle? This is not given in our metadata, so we'll have to calculate this, and this is 90 degree minus elevation, sun elevation angle. So we'll calculate this. zenith, and we can simply put the formula 90 minus this sun elevation. Okay, so we'll simply put the enter, and we'll have to calculate this in radian actually. So for this we'll just type this formula radians, and then we'll just click this and enter. So we'll get this in radian, and we're going to use this one also. So we can simply put this formula in also. So this is not needed for our calculation, so we'll skip this. So we are going to use these two formula only for our calculation. Okay, we have already prepared this in radian, sun azimuth and zenith. Okay, so this is sun azimuth in radian, and this is zenith in radian. Okay, now move to the terrain geometry and radian conversion. So we'll just put out DEM data into, convert our DEM data into slope and aspect. So for this we'll simply go to the arc toolbox, where we'll get the Spatial Analyst tool, and we'll just go to the surface, and we'll get the slope and aspect. So we'll click the slope simply. So input the data DEM, and we'll simply calculate here. I'll put this in new folder. Okay, so in art 1. Okay, so I'll put this in this folder only. So I'm going to calculate slope .df. Okay, save, and that's okay. I'll go to the result. So this is our slope. Now we'll calculate our aspect for this data only. So DEM, and I'll put the output raster folder. So aspect .dif. Okay, and then okay. So we have a slope and aspect data here. As we have to convert it into a radian. So for this we'll go to the map algebra and raster calculator. So for this, here we can visualize the formula slope into 0.174533. This is our formula to convert into radian, because 1 degree equal to similar to 0.01, approx value is 0.0174533 radians. Okay, so we'll simply copy this and paste in the formula. So I'll first convert the slope into radian. So into, and we'll put this value, and simply will calculate the slope and .df. Okay, save, and okay. So we have the slope in radian. Now we'll calculate the aspect in radian. So aspect into, and this formula, and we are going to give the path aspect radian.dif and save. Okay, so we have this aspect radian and slope radian. Okay, now we have already converted our solar zenith and solar azimuth in radians manually in our Excel sheet. Okay, now we'll go to the step 2, and here we are here we are going to calculate the IL, that is illumination model, using this formula. So we'll just copy this formula. Okay, we'll go to the raster calculator. I'll put it here. Okay, now zenith radian. So where is the zenith radian? We have this zenith radian, and we'll just copy this and replace it here. Okay, so this is a slope radian. Where is our slope radian? So our slope radian is, double click, it will be replaced automatically, and then we'll go to the zenith radian, which we have already copied. I'll just paste it here, and then we have the slope radian, so we'll replace it by slope radian. Okay, now we have cos azimuth radian, so azimuth radian, so we have the azimuth radian here, you can see. So we'll just copy it and replace it. Okay, by this value, and we are going to replace this aspect radian by our calculated aspect radian. So this is our formula, this is complete formula, and we are going to get the output path folder. So this will il.df. Okay, so we'll calculate this il. We'll see the il here. Okay, so we have il, we have already calculated our il. Now we are going for the step 3, where determine the constant. So this all functions we have applied on our DEM only. Now these all operations will be applied, will be calculated, that is constant, on Landsat data, that is optical imagery. Okay, so we have this data. For the calculation of constant, we have to create 30 to 50 random points across homogeneous land cover type. So we have to identify the homogeneous land cover type in our optical imagery. So, and in that particular region we have to create the 30 to 50 random point samples, and after that we will extract the multi-values points, and we'll go for the constant calculation. Okay, so first I will have to identify the region where the same land cover is there, but the illumination differences are there due to the topographic effect. So we'll just go to the catalog, and I'll just create my shape file and put the polygon. Okay, so I'll create a shape file naming forest, and it will be polygon, and what will be our, so basically we'll use our this where is this one, Landsat B3. Its spatial reference will be used in our polygon generation. Then okay, we have already generated our forest type, and I'll just edit the feature and we'll create a polygon. Okay, so basically I think this area is completely covered by forest. So I will generate this, save this and stop. Okay, so I have already calculated, and in this area we will create 30 to 50 points. Okay, so for this we'll go to the data management tools, and here is a sampling. We'll go to the sampling and create random points. So for this output location where we have to do, so in this Minnaert, in this one I get this point. So output feature class. So what will the class? So I'll put this name here. So on the name of random points feature class to be created. So I'll just put the name of this points is key points. Okay, and constraining feature class, that is our first area, and obviously number of point. So we are not going to get 100 points, we are just getting 40 points. Okay, this will be linear in it. Okay, you don't do anything in this, we'll make it default, all these things, and we'll click it. Okay, so it will create 40 points in this area only. Okay, so we have the points here, constant points, so we don't need any more this forest area polygon. So now we have to create the multi values to points. So for this we need the IL value, band value, and cos S, means S is our slope. So 3 values to be added in our these key points. So for this we'll go to the Spatial Analyst tool, and we'll go to the extraction, and here is the extract multi values to points. So we'll just double click it, and we'll go to the key points and input our rasters. So we have to calculate the IL, then line segment 3, and of course the slope radian. Okay, and click OK. Okay, we have these values. I can open this. So these are the values. We'll simply select all values and not in these areas. We'll go to this area only, and here we click the right click, and we'll go to the copy selected. Okay, and now we'll go to the paste it in our Excel file. Right, so we'll delete this and paste these new values here. So we have IL, Landsat B3, and slope radian. Now what we have to calculate is the X and Y. So we'll generate the 2 columns also with these formulas. So first we'll go to the we are going to create X, and now for Y, for X our formula is land. Okay, click and cos, sorry, we have the formula for X. We have to create IL dot cos S. Okay, so we'll simply put the IL and into cos. We'll calculate the cos and then slope. Okay, so now we'll just close the bracket and click it. Okay, now we have X, and now we are going to calculate phi. Okay, is equal to land, obviously, sorry, that's wrong. So here we have the land band value dot cos s. Okay, so and land ln and band value into cos s, right? So we'll just close the bracket and okay. So we have all this and we'll just drag it for all the points. So we have 39 points here. Okay, so this is our okay. So we have this much point. Now we'll going to create scatter plot. Okay, so we'll insert and we'll get this scatter plot. Create it. Okay. Now here we'll go for the trend line. Here is our trend line, and in this we'll go to the linear, of course, and this will be linear, and then we'll go to the more options. When we go to the more options, we'll automatically go to the trend line option, and here is our display equation on chart. So I'll just click it, display equation on chart. So this is our y equal to mx plus c, and this will be our constant for our IL or Minnaert correction. Okay, so we are going to just copy it here, simply copy it, and we'll put it in formula. Okay, so we have this much, we have already calculated this constant, and after this we are going to do as map algebra, and we'll go to raster calculator, and after this raster calculator, what we'll do, we'll just put this formula in our formula pen. So here is our satellite point, that is Landsat V3. Okay, now slope gradient, it should be replaced by slope gradient, this part IL raster, and this should be also replaced by IL, and then slope gradient. So it should be replaced by slope gradient and then K value. So what is our K value? We have already calculated this. So this is 0.0414, so we can just copy it here, or you can just put the number here. So we have copied and paste it here. We have the complete formula here, and now we are going to do Minnaert.derive. So save and okay, just wait, we'll get the complete Minnaert corrected image. So you can see here there is some balance between the balance between the topographic error. You can see if the same area is here, so this portion is completely this area had completely a different illumination than this area, but this whole area has the same land cover, but due to topographic effect there was different illumination. We can visualize it here, so you can see this So it just tries to balance the illumination each and every part of the image. Okay, so this is our Minnaert corrected image, and this is our in back of this image you can see the original image. So this is Minnaert correction for topographic correction. So that's all. You can see one by you can do one by one band for each and every band for topographic correction. Okay, so that's all. Thank you.